Good morning, everyone. Thank you for tuning in to BPTV. This is another one of our series, Handy Andy, and I'm your host, Andy Amrine. And the reason we're here today for a Handy Andy segment is I want to show you the Bethel Park Wastewater Treatment Plant. There's so many gizmos and gadgets and electronics and computers and pumps and everything else that goes along with it. I'm just amazed by this place. I love this place. There's an awful lot going on, and I think you're going to enjoy the show too. So stay tuned. Let me introduce you to Scott Dunn and the Bethel Park Wastewater Treatment Plant. All right, Scott, can you give me some history about this state-of-the-art sewage plant that we now have here for our community? Because I know you've just finished a nice big remodeling over the past year, but it's changed a lot in the last 30 years, 40 years. How about just walking us through a little bit of a history of when the sewage plant started and compared to where we are today?
Okay, well, the Sewage Authority, I believe, was established in 1951, is when the authority came about, when they decided to build a wastewater treatment plant. And they got together with South Park Township along the way that actually became a partner with them in this plant, and that's why it's down in South Park Township. Mm-hmm. So the treatment plant was actually constructed in 1957 and put into service in like 1960.
Okay.
Is when it was dedicated. And then from there, the plant worked very well. It was a very basic, it's what we call a trickling filter process treatment plant, where we have primary treatment, a biological process, then a final treatment and disinfection, and then goes to the Piney Fork Creek. Back in when the 72, when they passed the Clean Water Act, all the regulatory people started cracking down on the treatment plant. So that's when the first major upgrade of the treatment came about. And when they upgraded the treatment plant, that was in 1978. When they finished that next phase construction, they went from primary treatment to a biological treatment, but they made it, they changed the arms and stuff so you had better biological treatment. They added more final settling, and then they went to tertiary treatment, which was sand filters. And actually the building we're sitting in right now used to be the sand filter building, and it's been repurposed over the years. So the treatment plant worked really, really well for many years. And then the regulatory people again came in and tightened up the standards. And at that point, they make us nitrify and remove the ammonia nitrogen. So we had to, the filters, the way they stood from the 57 design and the first little upgrade, could not meet the ammonia nitrogen that we had. So what we did was our engineering firm, HDR, that we had at the time, turned around and they did an optimization study for the authority. And during the optimization study, they came up with a long-range plan, which we've been following, where it got us to the state-of-the-art where we are today. So in 2008, we, from taking the data from the optimization study, we did the biological treatment of the trickling filter upgrade, added a pump station, separated the flows out. So now the first filter, which we'll look at a little bit later, is a BOD removal filter, and the second one is a nitrification filter. And then we still used the old secondary clarifiers that we had in the sand filters. The treatment plant was back in compliance, so we have very, very tight standards here because that is a stock trout stream that we go into, so our numbers are very, very low. We have to meet 2 milligrams per liter of ammonia nitrogen leaving the treatment plant, which is pretty tough to do. So what we did is sticking with the long-range plan, we knew that our final clarifiers eventually were going to need to be upgraded. So the next phase project, which we just completed now in 2018 was we added 2 new final clarifiers after the trickling filters, and we go to UV disinfection because the regulatory people basically tells you you're not allowed to discharge any chlorine into the stream. So the easiest and safest way to do that is to go to UV disinfection. So that's where we're at that time, at this time right now.
It sounds to me, Scott, this is a lot more than just you have sewage coming into the building, you separate the solid and the liquid, and you pump the liquid back out into a stream. There's how many different steps? Do you have like 4, 5, 6 steps? And this water leaving the treatment plant, to me, sounds cleaner and better than anything upstream from the treatment plant itself, with all these steps and processes you have going through to meet the DEP, the EPA standards and so forth that you're under.
The steps that we take here at the treatment plant, we bring the water into the treatment plant. We run it through a grinder system to kind of basically grind up any big solids and send it to the primary clarifiers. And the primary clarifiers, what we want to do is settle out the heavy solids, so the heavy solids are not going through the rest of the processes in the treatment plant, and we're only having liquid, which is still has a lot of bad stuff in it. And that's what the next process is the biological process, is the trickling filters. So it goes through the first trickling filter, where it removes the BOD, which breaks down the solids. And then when that number...
So trickling filter water just enters at the top and it
trickles
its way down to the bottom?
And there's media inside of the filters, and the biological process, the microorganisms are attached to the media, and that's how the water gets treated.
So these are like live filters?
Yes, they are live filters. We don't use any chemicals here in the treatment plant.
No chemicals at all?
No chemicals at all.
Okay.
Everything that we do here is all biological.
Wow.
So once the BOD gets down below 30 milligrams per liter, and it typically comes into the treatment plant at 180, then you can get into the nitrifying bacteria, which is in the second filter, to remove the ammonia nitrogen. So it trickles down through the second filter, and then it turns and leaves that filter and goes to the new final clarifiers. So any fine particles that are left, so at this point here, the water is technically broke all the way down for all the bad stuff out of it, meeting the permit. So what we do in the final clarifiers is settle out the heavy solids, and the solids are BOD, so any fine particles or anything that's left will settle out in these tanks, and the water coming over the weirs is basically crystal clear. And then we run it through the UV disinfection. And
that's just killing more germs?
That actually will take all your fecal coliforms and eliminate them. So then you discharge into the stream as clean water.
Wow. Now, it's not drinkable, though? It's just...
It's not drinkable. If you would take the water to a couple more steps, a lot of people around the world take their water out of their wastewater treatment plants because their water is such a commodity that's so hard to find. It's precious. So basically, what they do, they go from their wastewater treatment plants right to their drinking water plants. Hawaii does that because they don't have a lot of water that's not salt water over there, which is very, very, very expensive to convert to drinking water. So you're not drinking water, but you're close.
Okay, but your process here, you're saying all these steps you have, there is no chemicals being used in this process whatsoever. It's all biological.
It's all biological. Now, every treatment plant for the biological processes typically lacks something in nature. This treatment plant, certain times of the year, lack alkalinity. So if the alkalinity drops low enough, which basically is what feeds the nitrifying bacteria, we'll add sodium bicarbonate, which is baking soda. So it's technically not a chemical. We we only feed it as we need it when the chemistry doesn't balance out.
Okay. But this plant operates. This is 24/7. 12 months a year. You're staff is here and you're always up and running.
We're always up and running. There are no days off in the wastewater treatment plant. The flow comes 24/7, 365. So Christmas, Thanksgiving, all the holidays,
Yeah.
we're working.
Now you have chemists on staff, lab people, plumbing, electrical. This has to be a lot of work to keep this plant up and running.
It is. The maintenance in a treatment plant is very, very intense. There's always things breaking. When the sewage comes into the treatment plant, there's a lot of stuff in it that really shouldn't be there. It's hard on the equipment. So the maintenance is always there. I do have my assistant superintendent is a certified lab technician, and we are an accredited lab. So we do all our lab testing in-house since we are accredited with the DEP.
No, I mean, when I pulled up this morning to get set up and everything for it, I mean, in my mind, and I assume a lot of people, you're going to say, oh, I don't want to go down there or live near there or anything. The smell is probably atrocious. Pulling onto the property, there's no smells whatsoever to this plant.
No.
That's part of the process and keeping everything and the biological process with it is the odor controls also.
Absolutely. If the treatment plant's working properly the way it should, you shouldn't smell any sewage going through it. You might get a little bit of musty smell, right on top of the processes, certain areas, but it should not smell like sewage.
And does the weather, the season at all have any effect on your operation as far as temperature outside or this biological process? Does it still operate just as well at 0 degrees as it does 100 degrees?
Well, in this particular treatment plant, we have some innovative technology in this treatment plant where our trickling filters are not your typical trickling filters that we have everywhere else that you'll see in the world. Actually, it's here in Bethel Park and Findlay Township has these only filters, but they're Dunn draft filters.
Okay.
And they do not bring any cold air inside, because basically what happens is your biological process shuts down at 50 degrees. It gets all of the microorganisms slow down, and they're very
They get
slow.
too cold.
They're too cold to operate. And in the wintertime, the DEP and the EPA knows that, so they'll loosen up your permit and let you go to 4 milligrams per liter when it's really, really cold outside. But this treatment plant nitrifies their ammonia nitrogen down all the way down to 0.2, 0.3, even at 20 below zero, because
Wow.
it doesn't bring any cold air into the filters.
So Bethel Park, South Park, we have one of the most high-tech facilities anywhere in the country.
Yeah, it's for the biological process.
For the biological process
working
and so
in the
forth
cold
on it.
weather, absolutely.
So another good reason to live here in
Yes.
this. So, well, how about if you show us a little bit about some of the technology that's here, and then we're looking forward to a tour.
What we're looking at now is the Scada System, and the Scada System is the system that actually oversees everything that's going on inside the treatment plant. There's fiber optic network throughout the treatment plant, which brings all the data back into the Scada system. Scada, it actually stands for Supervisor Control and Data Acquisition. So basically what is happening is you can basically follow all the complete flows through the treatment plant through the Scada system. So what we have is we have interceptors that come in from different parts of Bethel, and we have a pump station over on Horning Road. So when the pump station is running the Scada system as it is now, it comes on and you have a red light, and it tells you that the pump is running at the Lick Run pump station, and it'll tell you the pumps that are running. So the flows flow into the pump station and come to the main plant, which goes to the raw sewage, which takes the flow data into the wet well through these control points, and depending on how much flow is coming into the treatment plant, it'll tell the variable speed drives, which we have here, on how fast the motors have to run to pump the sewage that's coming in. Every pump station throughout the treatment plant has its own SCADA computer, which comes back to this main screen. Then we have our trickling filters, which is the biological process, and it all works the same way. They're all wet well set on predetermined levels. The difference is on the trickling filters, we have recycle to recycle some of the flows to get some of the biological back up onto the filters. So we control the recycle all through the Scada system. Then after you go through the biological process, it goes in to the final clarifiers, which settles the solids out, which then in turn goes to the UV disinfection building. And when you're done in the UV, you have an overview of the UV system, which tells you the light bulbs are all on at this particular time for the flow that we have, and you can actually go in and look at all the light bulbs. And if you had light bulb failures here, these lights would actually turn pink, would tell you that you had a light bulb out. The other thing that it has is was what we call the wet side of the treatment plant, so that's the flows coming through, but we have to process the sludge, so we have our digester control on here also, which we can keep track of the methane gas and the pressures in there and the levels in the digesters from this control screen. The nice thing about the whole system is we actually have trend settings in it. And one, like here on the trend settings that we have here, this is the flows coming into the treatment plant. So it's all kept in the computer database, and we can have a digital file on what was coming into the treatment plant. The other thing that the Scada system does, it has an alarm system. So there's predetermined alarms that are actually set throughout this entire treatment process. So if something fails from a drive to a pump to no flow, generator failure, it will give us an alarm on the Scada system, which in turn is set up to a 911 dialing system, and it sends text messages out to my operators. And if our phones don't pick up and we don't acknowledge it, then it'll call, and then it'll go to a backup auto dialer system. So if somebody's working out in the yard or on one like second shift where we only have 2 people and they're working and they're not in this building watching the Scada system, there's ways that they're going to get notified that there's a problem somewhere in the treatment plant. And the other thing that we do out on the buildings when we go out and take a walk, we have flashing lights, and they will go off on failures too to let guys know that there's something, that if you miss something you're working on.
I noticed on some of those screens there's 3 pumps, 4 pumps, and you were only using one.
Correct.
So depending on the flow or maintenance-wise, you have a lot of backups to the systems itself. So a complete shutdown failure really you would be hard-pressed to have that.
Yes, well, according to the DEP regulatory rules and the EPA, everything in a wastewater treatment plant must have a backup.
Okay.
You can't have a single source of any particular pump.
So even power failures,
Yes, the treatment plant is completely generated. I have 2 750 kW generators that can run this entire treatment plant for days.
Okay.
If you would have a major
power outage.
The biggest thing I would need to do is bring diesel in, which I keep 900 gallons of diesel in each tank. So if we'd start running low, we can just bring diesel in and keep it going.
Okay. And electricity, those UV, those are really just light bulbs?
They are just light bulbs.
Okay.
Correct.
And how often do you need to change those?
We've been running since January 2017, and we haven't had anything. I believe it's 5,000 hours.
Because in the world of the LED and the longer life,
Yes.
and it's the same thing with UV bulbs. They can be LED and long life and so forth.
It can be. The difference in this system that we have here, UVT is a method that we use to read the clarity of the water going into the UV bulbs. And basically the bulbs work on intensity. Like most of your systems, your older systems, and when the UV first came along, all the bulbs are on full blast all the time. As we go back into here and we look and see, with the UVT right now, this system and the flow, it's based on the calculation of 2, which is all done in the computer systems. I only need 2 banks of bulbs on right now if the flow would come up to do everything. But the unique thing about this system is the intensity of the bulbs will actually change before you bring on the next system. So it'll be at a low power. And if the UVT starts going down where the clarity of the water is good, and that's how they're looking to add how much UV light, the bulbs will get brighter. to meet your numbers.
On same basis, though, on your trickling filters and your high-tech filters and so forth on it, is this something that takes a lot of maintenance or back flushing, or do you ever have to change them, or are these good, you set and you run? And
Well, the nice thing about the trickling filter process, it's basically a self-contained, self-cleaning process.
okay, so as
if-
long as you don't lose your microorganisms,
Correct.
the system is going to operate.
It'll operate fine. And then the biggest thing on a trickling filter is you want to make sure that the media stays open and doesn't plug. When you have rainstorms and stuff and you put over 12, 14 million gallons up on the filters, they flush themselves out and keep themselves
Okay.
clean. I know on other parts of the country where they don't have a lot of rain, there was a gentleman in Salt Lake City came up with a process where these arms that go around are actually motorized, where they could actually slow them down with the computers to flush the filters out. We don't have to do them here. We have that capability because all the arm systems that you buy today come with that capability.
Okay.
So, like I said, we don't need to use that, but they run themselves.
Yeah. How about the skill of your staff? I mean, it's a lot of high tech, a lot of computer, a lot of engineering, chemistry.
Yeah.
Your staff must be a pretty well trained staff.
Well, my guys, it's not me or Jake that run the treatment plant. It's the employees that do it. Most of my employees are certified operators.
I was going to ask you, are these trained, educated, certified type?
Yes, they're certified operators through the PADEP. There's a lot of continuing education that comes along with that certification. So they have to do their 30 hours every cycle. And then just to keep up with all the new technology that's coming along.
Yeah. Security, safety of employees and building and so forth, any concerns?
No, the treatment plant, we run a very, very intense safety program here. We do training. We do toolbox talks on Thursday mornings here.
Mm-hmm.
When I send the guys to classes for their continuing education, the first thing we do try to send everybody to is safety classes first, because it is a pretty dangerous place to work. The falls could be high. The tanks are deep. We use there's a lot of confined spaces throughout the treatment plant, so you have to know the confined space protocols. High voltage, 480 volts, everything runs on three-phase, so electrical shock is pretty high possibility. So safety and how to do things, and the big thing is, if you don't know, you need to ask. My guys just don't jump into anything till everybody here is comfortable on what we're doing.
Yeah, turnover. Your staff here, I've seen them here for years and years. They've, been here a lot of years,
Yes.
just like yourself.
Yeah, basically, it seems to be once the guys come to the wastewater treatment plant, they don't leave.
normally don't
They
leave.
normally don't leave. They
Yeah.
stay here till retirement. So it's a good job. It's a good way to make a living. It's done well for me and my family, so I have no complaints.
And you started pretty much just one day walking in, and you've worked your way up to the top.
Well, I started out up in the road department. I'm a diesel mechanic by trade, and then when Bethel Park had their own rubbish removal and had their own garbage trucks, I was hired as a diesel mechanic on the garbage trucks. Then when they transitioned, got rid of the garbage trucks and subcontracted that out, an opening came up in the wastewater treatment plant for a mechanic. So I transferred down here, and then I started going to school at night. And my long-range plan was to try to work my way up. So I continued to do my education. Then I got certified and moved up to where I'm at today.
Now you're here.
Now I'm here.
Sounds good. Well, how about taking us on a tour? I'd love to see the place.
Sure.
All right, Scott, we're in, I guess, one of the older buildings on the property itself, one of the original buildings, but this is where everything starts. So tell me a little bit about the process.
Well, this is what we consider the raw sewage pump house.
Okay.
So earlier we were down and we took a look at the grinder room, and that's
Okay.
where the interceptors all come together right outside, and the flow goes in through the grinders.
So the sewage from the houses and also
Houses.
the substation and everything is into there.
Correct. All the sewage flow ends up in front of those grinders. It goes through the grinder system, drops down into the wet well.
Okay.
Then we took a walk down to the basement where the raw
Okay, now that
sewage
basement,
pumps.
you're talking 3 stories, almost 75, 80 feet
Correct.
below ground. I mean, it's pretty deep.
Yes, it is. You know, the biggest thing with wastewater treatment plants, because everything basically works off of gravity everywhere you can, so you bring the water in low and we pump it up high so then it'll gravity to the next process.
Okay.
So we
So
went
if
on.
people drive by this treatment plant, it's really a story, maybe 2 stories is all they can actually see from the street. But what they don't understand is you got another 3, 4 stories that are below ground on this property.
That is correct. Most of our buildings here do go down 3 stories to the basement.
Okay.
So the flow comes in into, like I said, through the grinders into the wet well. There's wet well level sensors down in the wet wells, which we're reading here on this screen. And these screens that we have here are the same screens that we looked previously on the Scada system.
Okay. So it's showing one pump right now is
Yeah.
operating.
Correct. Right now we're showing one pump that's running, and we're pumping 4 million gallons to the primary clarifier.
4 million gallons of water
per day
per day,
Per day.
through the grinder.
up into the primary clarifiers.
Okay.
So this is controlling the raw sewage pumps. From here it goes, like I said, to the primary clarifiers. All these pumps are running off of VFD drives. So as the flow goes up, the pumps will ramp up. So right now, a full speeded pump would be running at 60 hertz. We're only running at 48 hertz there on the first pump. So before another pump would come in, its pump would go up to 60 hertz and another pump would come in to help.
And it'll do that all automatically.
Everything is done automatically, and it's all set by these level settings that we have predetermined into the computer
Okay, now
system.
this building, though, was built in the 1950s?
This is a
was it?
1957 built building.
Still looks pretty immaculate to me.
Yeah, the building's in great shape. When they built the building in 57, they used all glazed block, which makes it very nice to keep it clean. We did a major electrical upgrade in this building in 2008. That's when we went to the first phase of the Scada system. We went to the high-grade computerized VFD drives. All the motor control centers are now state-of-the-art. So we're trying to keep with the times as the trend keeps on moving on.
You have to.
Yes.
Have to with it. So where to next?
We're going to go out and take a look at the primary clarifiers where the raw sewage pumps are pumping the water to.
All right, Scott, what are we looking at out here? These look like a lot of tanks, a lot of railing to me.
Yeah, there's a lot of railing, a lot of stuff to keep clean out here. These are the primary clarifiers.
Okay.
So
and
when
what
we
does that mean?
So basically what happens here is we were down in the raw sewage pump station, we looked at the pumps. So the pumps have to pump the water somewhere. We pump them to, out here we have a primary distribution box.
Okay.
So what you want to do through all your processes is try to keep your flows as even as possible. So there's actually baffles in there that's sending the water to these 3 tanks that we have out here on our primary clarifiers.
Okay.
So the water flows in the front of the primary clarifiers. And if you can see on the back here, that's actually like restaurant grease and stuff that comes through the system. It's all your floatables.
Oh, okay.
Okay, that's a manual process that we have to deal with weekly, that we remove that and add them to another process, the sludge process in the treatment plant.
Okay.
So what happens here is the heavy solids settle out in the tanks. These chain and scraper system goes the whole length of the tank down underwater and drops into a cross collector, which there's a hopper that's about 18 feet deep down on this end of the tank.
Okay.
So the heavy solids end up in the hopper. Then we have an automatic pumping system that takes the heavy sludge and takes it up to another process, up to the sludge thickener. And when we get to the sludge processing, we'll discuss exactly what happens there.
Okay.
So on the back side of that wall there, the tank continues. That's just a baffle to stop the grease so the grease doesn't go on to the next process. There's V-notch weirs back there so that the water, nothing heavy or large, will move on to the next process, which will be your biological process.
Okay.
Okay.
And then do you ever have to, maintenance-wise, drain these, clean these, fix these?
Yes, the maintenance, we drop these tanks 3 to 4 times a year, depending on how much rain we get and flow.
Okay.
You get debris in them, you'll get grit in the tanks you have to clean out. We will have to change the shoes on the tanks, adjust the chains. Every year we change all the oil in the gearboxes and just basically keep it, the maintenance up so everything keeps running without any failures for us is the goal. Try to catch everything before it happens.
Right. Okay, so from here we're going to
We're going to go to the biological process.
Nice. All right. All right, Scott, this is probably what most people see when they drive by a wastewater treatment plant. They see big tanks. So we got nice, pretty, big blue tanks. How deep, how tall are these going down in the ground, and what are they? Are these the trickling filters, I guess, that you were talking about? Is this step one of the filtering or what?
Yes, you're correct. After, like we discussed before, the water leaves the primary clarifiers,
Okay.
and all the heavy solids have been taken out of it, and you want to take it to the biological process. This first filter behind us is the trickling filter number 1. So the depth of them are not in the ground, but a very little bit.
Okay.
The total height of them, and we'll go up on top and take a look at the media when we get up there, but the media doesn't start to the right at the blue wall.
Okay.
Okay. Underneath of these filters, they're kind of very unique. There's stormwater storage plenums, which in turn creates our downdraft system. When we talked about
okay.
the downdraft, it's
Right.
created from that storage system. So we can actually store 1.8 million gallons of stormwater that would normally end up in the creek as pollution underneath these filters
Right.
on a bad rain event. So there's 6 foot of what we call plastic cross-flow media is where the home for the biological process to work. And for any biological process work, you need 3 things. You need food source, which is the wastewater leaving the primary clarifiers.
Okay.
You need somewhere for the microorganisms to live on it, that would be the media, and you need air. Those 3 things basically will keep everything alive. And our goal is to feed the right amount of water, remove the right amount of solid so that the process works properly. Our job here at the treatment plant is to balance the biological so everything works properly.
So the water is entering from the top
And trickles
flows
down through to the bottom. Behind us here, these are flow distribution boxes.
Okay.
And we looked earlier on the Scada system, we talked about the recycle. So we control the recycle through these gates, which are automatically tied to the Scada system and the control system in the treatment plant.
Okay.
So the water leaves this filter here, flows over into this pump station behind us.
Okay.
And we can take a look at the recycle here. And the pump stations are exactly the same as we already looked at. There are 3 stories with the pumps down in the basement and the
Okay.
controls and everything upstairs. Pumps up to the second filter, which is a nitrification filter.
Okay.
And once it goes to the nitrification filter there, then it'll go to the final clarifiers.
Okay. So it's
Okay.
just 1, 2, 3, and
1, 2, then
just keeps getting cleaner and
keeps
cleaner.
getting cleaner as we go.
All right, Scott, explain a little bit about what we're looking at back here.
Well, we're on top of the biological process, the downdraft trickling filters, and what
Okay.
you're looking at is the distributor arms and the black grating that looks like grating. It's basically big cubes of plastic cross-flow media. So the water gets pumped up to the clarifiers, I'm sorry, to the trickling filters,
Okay.
and it gets distributed through the arms. And these here are actually running off of gravity. The flow of the water is what's turning the arms on these
Really?
particular ones, yes. So the water comes out of the arms, and we can adjust the speed by putting brakes on the arms. As you can see, we're slowing them down. So through trial and error and working on getting the best process, we figured out the best way to meet all our permit here. So the water then trickles down through the filter, through all the media, and it hits the biological on the way down, comes out the bottom of the filters over here, and then leaves this trickling filter and ends up into this pump station behind us here.
Right.
And gets pumped up to the second filter, which is behind us, is basically a mirror of the same thing.
Yeah.
This is where we remove our BOD at this filter here, and this is where we remove our ammonia nitrogen.
But it's the same process, same filters and so forth. With
The construction of it and the physical components of the filter are the same. The biological is different because
it's just what you have eating is different, the biological in it.
absolutely. So, I mean, a good way to look at it is the biological that we run here in the treatment plant is the same things that happens in nature. When you're like walking down a creek and you see that slime in the creek and the algae and everything, that's biological process which is cleaning up the creek.
Okay.
We basically have the same identical thing that you see in nature, but we combined it and contained it into this area so that as the water goes through, it will treat the sewage there. And it multiplies because the sewage is the food.
Right.
And then
So there's a lot to eat.
the population will keep
a lot
on
to eat.
getting stronger.
Do you ever get overpopulated?
No, well, what would happen is that's why we have the flushing system on some of them. We do have the opportunity on these filters. You can look up on the top. There's motorized drives. If we got into a dry season and we could not flush the filters properly,
Okay.
I could set them up to the computer system where they would slow down on low flow in the middle of the night and take like an hour to make a revolution. It'll flush out anything that's not attached to the media.
Okay.
If it gets flushed off, it's dead. It's already moved. And that's what the purpose of the final clarifier is for, so basically to pick up all that dead microorganisms that no longer are used. We have to get them out of the system before he goes out into the stream.
All right, so Scott, this tank here, this is, I guess, one of the newer ones that are on site, but this is your final settling of it, or step 3, or how do you refer to this one?
Yes, these are the final clarifiers. It's the final settling process. So anything like we discussed earlier that got through the system or dead microorganisms that came off the trickling filter, we need to get all that out of the process.
Okay.
Before we can discharge this stuff into the stream. We do have a suspended solids number on our permit, so we got to keep that number down. And actually, suspended solids relates to another part of our permit, is our BOD number, and solids equal BOD. So you want to have the solids down, or keep your BOD number down.
So when this all settles,
Yes.
what do you do with all the waste or the settlement of it?
So what happens is the water comes in the center well of the clarifier,
Okay.
comes out through this baffle system,
Okay.
which slows the water down. The solids fall to the bottom,
Okay.
and the mechanism runs continually. It takes an hour to do a revolution.
Okay.
Once a day, we pump the tanks, we pump the solids off the bottom. It works as a vacuum system, and we pump it back up to the sludge thickener where we put it in through the sludge process.
So it just starts
Starts again. Starts again, but it starts on the sludge process, and we'll get up and we'll look at. We consider this the wet side of the plant, and then we have the dry side or the sludge side of the treatment plant.
Okay.
And like the primary clarifiers, these have weirs also, which are on the outside rim of the clarifiers here. It's this green assembly that you see here. So all the clean water goes over the weirs and then it heads over to the UV disinfection process.
Okay. So from here, we're going into the UV process.
Correct.
Okay. All right. Scott, what's this building here then?
So after the final clarifiers, it goes over to weirs, and the last process before it goes into the stream is the UV disinfection. Behind us here are the 4 UV modules. Like I said earlier, that are controlled off of the UVT and flow. It's a calculation that is done on how many bulbs have to be on to do the disinfection to meet our fecal coliform limit on our MPDS permit. In the back corner there is a 24-hour composite sampler. So for us to meet all our permit numbers, we have to do 24-hour composites, which are basically flow paste off of the flow meter over here on the wall. It takes a certain amount of sample to the flow to make sure that we make our permits.
Okay, so this is just water flowing underneath light bulbs?
It flows through the light
So
bulb.
it flows through the light bulbs itself.
Yes, the racks of light bulbs are about 12 feet tall. They're sitting down in these channels here.
Okay.
Now there is a lot of maintenance on the UV bulb, especially in the summertime, because when the water gets so clean, you'll start to get algae and different things growing. So what the operators need to do is shut the system down one at a time, one group of bulb, and shut a channel down. And there's a acid tank, which is technically not a strong acid. It's basically orange juice, where we dip the bulbs and hand clean them to make sure that we're getting the right UV light onto them.
Okay. So the ultraviolet light is actually killing
Correct.
the bacteria, germs, and so forth that would still
Correct.
be in the water.
Yes, it
And then
is.
from this building here is where it flows directly back into the creek.
Correct. It'll flow out into the Piney Fork Creek from here.
All right, last step, Scott, is we're outside the UV building with our stream in the background, and the water's just coming after it's gone through the UV process, and it's just put back into Mother Nature then.
Yes, it is. I mean, at this point here, it flows through a channel. We actually have a flow meter in the outside channel, which gives us our official numbers that we treated through the treatment plant in the 24 hours a day, keep everything on a chart recorder, and then it gets discharged into the Piney Fork Creek behind us.
And what's an average day flow
This plant averages about 3.8 million gallons a
a
day.
day?
And during a major rain event, we can put 17 to 18 million gallons through the treatment plant and still stay in full compliance with all our numbers.
As far as treating, so there's no waste going
There's,
back into the...
there's no waste, anything going back
So,
in.
and I know your guys that work here, I've heard them joke before that they go fishing right where it comes out.
Oh, absolutely. There's people fishing here all the time. There's actually...
Is this a stock trout stream?
Correct. There's actually fishing holes right down on the bend down here. The kids are in there all the time. It's a catch and release stream. They want you to put them back in, you know, but they're always fishing down here.
Nice.
They have no problem with keeping the fish alive.
It's all a good part.
Yes.
You know, I love your plant.
Thank you.
All right, Scott, this doesn't look like much from the outside, but I know inside this goes a long way down. What do you call this little bubble here that we have?
Actually, this is our stormwater flow equalization tank,
Okay.
and it's actually at the head of the plant. The Piney Fork interceptor comes down behind us here, and there's a diversion chamber, and if the treatment plant is overwhelmed from rainwater from a really bad storm or snow melt, instead of dumping the water that you can't treat into Piney Fork Creek, polluting the creek, we store it here in this flow equalization tank.
Okay.
So this tank is 100 foot in diameter and 30 feet deep, and we can hold 3 million gallons of water in this tank.
And then just process it later in the week or the month or whatever.
Well, we want
until-
to try to empty it right away. As soon as the flow comes off enough in the treatment plant after a
You start
major rain
pumping it
event,
in.
we pump it out because you don't know when the next rain event's going to happen.
Okay.
So you want to have all the defenses that you can ready to go for the next rain event.
So it sounds like you've thought of everything.
Yeah, the engineers did a good job on laying everything out, so it works well.
All right, and what's the next building?
The next step is we'll take a look at the sludge process. So we talked about on the primary clarifiers, and on the secondary clarifiers, we pump the heavy solids out to a sludge thickener, which is no more than a very small 30-foot in diameter clarifier. So basically we want to get the solids percentage up, less water, to feed to our digester process.
All right, stop behind us. We've got a couple big dome buildings, digesters. Is that what these are?
Yes, we talked about the sludge process. After you removed all these solids from the treatment plant, now you have to process them the same way we process the water that's flowed through. This
Okay.
is another biological process.
All right.
So what happens here is we take the solids into the sludge thickener and we try to get the solids up to at least 5%, 6% solids. So every day we feed 11,500 gallons of sludge to digester number 1. And this is a two-step process also, like the
Okay.
trickling filters. Basically, the digesters are exactly like the human body, your stomach. We feed the sludge to the digesters. Once we get the biological process going, we heat the sludge. We take it up to around 90 degrees, 86 to 90 degrees. The sludge, there's methane fermenters in there and different types of biological processes like we have in our bodies.
Okay.
It heats up the solids, creates methane gas. These big domes that we see on top are basically gas holders.
Okay.
So we are containing the gas, and we're use the gas back to a heat exchanger to heat the sludge. And any gas that we're not using gets flared off through the waste gas.
So
line.
you're actually reusing even the methane into this building
Yes,
itself.
yes,
to
we
make
are.
the building even more efficient.
Yes.
Amazing.
So Then from there, we don't heat the second digester, but with this new diastore process with using the domes, they're actually tied together now. It's two separate processes, but they're actually together because one's heated and one's not.
Okay.
So it still has more digestion than the second one. The heavy solids settle to the bottom. And then what we do is, instead of processing so much sludge and water, we try to shut off the mixing systems that we have built into the digesters.
Okay.
And want the solids to settle to the bottom, and then we drain what we call supernate off of the top, which is crystal clear water, back to the head of the plant for processing. So we try
It's
to,
amazing, one big circle.
it's just one big circle.
All right, Scott, inside the digesters now, that's where we're at.
Yes, this is the digester control building, which actually sits between digester 1 and 2.
Okay.
On my left is digester 1, is digester number 2. And then we talked about the gas membranes on top.
Right.
For a safety feature, they're actually a dual membrane. You have an inner and an outer. And what we do is we blow fresh air with these blower systems between the membranes, and the gas pushes up against the inner one. So you have air between the outer one and the inner one, and you got gas on the inside, and creates a differential pressure on the digesters. So with having that system, then we monitor the air between the membranes. So if there would happen to be a leak on the inner membrane, we would know that through our alarm system.
Okay.
So there's methane gas detectors that are built into the membrane system, which are up here behind us here on the wall. And one thing that we do here in this treatment plant is anything that has to do with hazardous gases and everything, we contract that stuff out to the manufacturers of the equipment to make sure it's certified and correct. So there's no chance that somebody thinks they know how to calibrate and everything to make sure
So
it's
they're
safe.
constantly coming in here, checking and recalibrating the
We're set up every
equipment as
6
needed.
months
Very good.
to come in there and calibrate all our meters to make sure that we're completely safe here, keep the guys safe.
It's good safety.
And then the other thing that we do have, we have methane and hydrogen sulfide detectors throughout these buildings over here, just because the gas is a hazard in wastewater treatment.
Right.
And we monitor the buildings all the time.
All about safety. All right, Scott, I see a lot of gizmos and gadgets and pumps and valves. What are we looking at down here?
We're in the basement of the sludge processing building.
It's about 2 stories down.
We're about 2 stories down here. And what we do here is, we talked earlier in the primary processes as the chains of flights put the sludge into the hoppers. We have these pumps down here, our Wimco pumps that actually pump in the sludge to the sludge thickener, which is a very small clarifier, which we turn around and send it to the first digester.
Okay.
And all the rest of the pumps and valves in this basement is basically how we move the sludge around the treatment plant for all the different processes.
Okay.
Now the new final clarifiers do have pumps in the basement of that building, of the UV disinfection building.
Right.
Because it's so far to push it, it's easier to push the sludge than it is to pull it.
Right.
So once we get it up to this part of the plant, we can move it around with the pumps behind us. And then we have recirculating pumps here. We talked about the digesters and feeding the digesters and
Right.
heating it. So to heat it, we have to recirculate the sludge to a heat exchanger, which sits over here in the corner behind us. And we use the methane gas to fire that heat exchanger to
Right.
heat that sludge.
So the methane it produces is brought back down
Brought
here
back
to
through
fire
here.
this up like a big water heater to heat things up, and away you go.
Yes, that is a water bath heat exchanger, so you heat up the water, which then in turn heats up the sludge and brings it up to temperature. It's all automatically controlled. So basically this is how we move everything around and all the solids around the treatment plant.
It's very clean.
Clean
Give you a lot
as-
of credit.
Guys do a nice job.
Yes, they do. All right, so what are we looking at here, Scott?
This is actually the final stage of the sludge processing.
Okay.
So after it goes through the digesters and all the bad stuff is eaten out through it biologically and it settles down, we have to do something with the sludge.
Right.
So what we do here is we take it to the landfill where they use it for cover up there.
Okay.
So before you're allowed to take it to the landfill, though, you have to dewater it. So what we do is these are sludge presses, and these belts are like fishing line, and the water will actually run through these.
All right.
So we put the sludge on the top, and it runs through this double belt system and squeezes the
Squeeze
water
it
out
out.
all the way down, and it drops off the bottom and then onto the conveyor belt behind us. And then we have our own dump truck that we load the dump truck and
So
take
the
it to the
sludge,
landfill.
when it's pressed and dried,
Yes.
you put it in your dump truck and you take it to the landfill.
Yes, I take it to
But
landfill.
that's good dirt. You're making organic soil is what
Yes.
you're actually making for it, which they, I assume, are happy to get.
Yes, they take it up there and they use it for cover on their landfills, mix it in with their other topsoils,
Okay.
and they use it there. We actually have a very nice arrangement with the landfill. Is they have leachate, which is produced through their capture system at
Right,
the
they're leaching and
landfill,
capturing.
and we actually have a line from their ponds pumped to us. So I treat their leachate off of their landfill,
Okay.
and in turn they take our sludge. So
Pretty good.
And one of
Saves the taxpayers a lot of money.
yeah, actually in wastewater treatment, it besides electricity, it is your highest dollar amount to get rid of is your sludge. So
And Bethel doesn't pay for that
we
at all.
don't pay for that at all.
It's
So
amazing. Okay. So you're giving them some organic soil
Yep,
and you're just treating their water for them.
correct.
It's a nice partnership.
Yeah, and actually, what really helps me out really well is there's a lot of good things in the leachate. They're
Okay.
very, very high in alkalinity. So if they send me enough leachate with the alkalinity up real high, even though they're high in ammonia, I won't have to spend the money on all the sodium bicarbonate at that time, and it makes my nitrification process work that much better. So
It's a very good
It's
partnership.
a win.
I'm glad they're close.
it's a win-win process.
All right, Scott, to me, this looks like what I see on the news when there's an earthquake. So are you monitoring earthquakes too?
No, we're not monitoring earthquakes.
Okay.
As part of our NPDS permit, we have to keep track of everything that we do in the
Okay.
treatment plant.
Or the regulations
For all
and
the
checks and
regula-
balance?
Correct. So what we have are these chart recorders. They've been here forever. It's as long as I've been here, and
Okay.
these are the newer styles. I know there's some people going to the new electronic and then printing out off of the electronics, but I personally like this style
Right.
recorders. It's easier to keep track of different rain events and different things that happen in your treatment plant
Okay.
by the dates.
So if any of the DEP or EPA or whoever your regulators come in to monitor, they can see everything they need off these discs, even if, for some reason the computer was hacked or something like that, that's like,
Yes, basically this is a hard copy of exactly what happens in the treatment plant.
nice.
So we actually have the influent flow is the water that's coming into the Piney Fork treatment plant here. Down on this chart recorder, we have the flow that's getting pumped out of our lick run pump station. And if for some reason we get a catastrophic rain event or hurricane come through here and we do overflow that big EQ tank out in the back, that has to be recorded also, and that's
As far as how much.
how much is there. Then
And now you do a disc a day?
Yes, every 24 hours we change the disc. Now the oddfall chart, what used to be here, but when the plant was upgraded, that chart's down in the new
In the
UV
new
building
building.
because we talked
That's where
about
the flow is.
that's where the flow's at, and we talk about the 24-hour composite samplers.
Right.
So we needed that flow meter and chart down here to operate the samplers.
Very nice.
Okay, and we do, out in the hallway, we have another bank of these charts where we keep track of the temperatures in the digesters, we keep track of the rain data, and the flow coming from the landfill, the leachate flow. So we can monitor everything that's coming in and out.
Pretty open book.
It's very open. And when the regulatory people do come in here, they will periodically look at our daily sheets and pull out these charts and
Make sure it's
checks
all
and balances and make
balances
sure
are there.
everything is all there.
Okay, very nice. Okay, this looks like a regular chemistry lab up the high school. Is that what we're looking at?
Yeah, actually, as part of our last upgrade, we talked earlier about repurposing the sand filter building, which made it
Okay.
our lab office and restrooms and all our new facilities here. We put in a new lab to meet the lab accreditation program. Like I said earlier, we are an accredited lab, which means that we're allowed to do all our testing for our permit, our NPDS permit in-house. So Jake Miller, my assistant / lab technician,
Okay,
is a certified lab tech. He's a Pitt graduate, and he comes in here and does all our lab testing and keeps us all in compliance. And when he sees things that aren't right, and him and I get together, he brings it to me. He does a really, really good job of finding problems before they happen. We do a lot of trending and graphing different things throughout the treatment plant, especially as the seasons change, to keep track of what's going on and try to head things off before things happen.
Keeps the sewage plant in compliance year-round by
Yes.
having it all in-house like this. You don't have to wait for somebody to get your results back, and that's 2 weeks and it's already too late. Having it all done in-house has to be amazingly efficient for the municipality.
Yes, it does. It is. And the other thing is, like, there's a few samples that we do have to send out some of the metals because it's just not cost effective for us to run those few tests a couple times a year, to have all the equipment here to run them. But if in the future, if some of the nutrients that could come along and permits down the road, we will update the lab equipment to accommodate anything else that's coming down in our NPDES
It's a nice sized lab, and it looks like it has room for growth.
We did. When we actually laid the building out, we wanted to make sure that, if for some unforeseen reason that there's a big building boom, and Bethel's built out pretty well, but South Park Township still has a lot of growth left in it. And if they would change our permit and make us sample like 7 days a week, we don't have to do 7 days a week now. But if they would push us into doing something like that, that I have room for bodies to work in this facility.
Okay. Well, talking about upgrades and so forth, where do you see the sewage plant, next year, 5 years from now, 10 years from now? I mean, I know you just finished, 2 years of renovations and upgrade. Is this an ongoing process that you're going to be doing this again and again?
Well, basically, we talked about the long-range plan that we developed back in the early 2000s, I believe it was 2003. So we have completed everything as part of the long-range plan. Moving forward, we opened up the space when we gave up the old final clarifiers for the new headworks for the treatment plant. That's the last phase of the long-range plan that we have set right now. The only other thing that could push us into any other upgrades is the regulatory people. If they tighten up our permit or add more things to the permit, then I have to upgrade the processes. There's always been talk of nutrient removal throughout these treatment plants along the way. So when we did the final clarifiers, if you notice when we walked down here, there was a big kind of open space between the trickling filters and the final clarifiers.
I saw that.
That space was there on purpose for another biological process that could be added.
Okay.
The piping is actually in the ground, and the T's and everything.
Wow.
We've
Okay.
already sized that and designed that in for the future.
Scott, what an amazing day. I can't thank you enough for showing us around this. You have to be pretty proud of your plant. And I say your plant, but I mean you oversee the plant, but it's the municipality, Bethel Park, South Park Wastewater Treatment Plant. But you and your staff are to be commended. This is a gorgeous facility, cleaner than I would have ever imagined. And you have to be proud of it.
Well, thank you, Andy. I mean, it's not me. It's basically all my employees that work here. I mean, everybody just takes pride in this place. They do what they're supposed to do. They basically have taken ownership of the place themselves. So it works.
Shows.
It works really,
It shows.
really well.
It's something that the community
Yep.
itself should be very proud of. And so hopefully someday some of the residents will actually have a chance to see. But if not, that's why we did the show today, just to show off quite an amazing achievement of the municipality and having this facility here.
I appreciate you guys coming down. I mean, it is probably the biggest investment that the taxpayers from Bethel Park and South Park, on the portion that they pay, own in Bethel Park. So we're pretty proud of it.
Well, wonderful. Well, thank you everyone for tuning in. I'm your host, Andy Amrine, and we do appreciate you watching BPTV. We'll see you again soon.